So when you have a word problem this basic, all you have to do is take these words and turn them into a mathematical formula. So Sharon sold 15 more lollipops than Aaron. So let's make Sharon SH because that's her name, and that way we can keep her separate from Selena. Let's make Selena SE. Okay, here's another thing. If you are running out of time, most of your tests are taken on a computer. You can also make a notepad in your head. You can also do a mental map. If Aaron sold 8 lollipops, which you already got, more than did Selena, all you have to do is find out how many Selena sold. So Selena sold 3. So you already know that you already know your answer is 11. So A equals 11. Because Aaron is 8 plus Selena, and Selena's 3. So you could easily put this 3 here. That's going to equal 11. Now, Selena is 3. 8 more than did Selena is 11. And Sharon sold 15 more lollipops than did Aaron. So 15 plus 11. Okay? And if your mind is able to work this quicker, the more you do these, the quicker your mind is going to get. So it's going to be 26. Now, how many lollipops did Aaron sell is very easy. That's 11. How many lollipops were sold in all? Now you have here this number, 26, 11, and 3. So 26 plus 10 is 36. 1 more is 37. Plus 3 is 40. Do your math. It's done in the word problem. So just to tell you that even though words are in front of you, please don't feel so badly that even though you have words in front of you, you still have to know what these words represent. So you have here, Sammy and Andrew collected marine life samples. Sammy collected 100 marine animals, including fish. Andrew collected 25 marine animals. 40% of Andrew's marine life samples were alive, and 20% of Sammy's were alive. What is the total live sample of marine animals collected? So here's even some wording for you. Because they tell you the total life and they leave the total live sample and they leave it out, they mean they want the combination of both of these people, Sammy and Andrew. As you advance along the way with algebra and algebra 1, algebra 2, and eventually if you go into doing college math, college level math, you go on to do math like for an MBA, for actuarial science, any of that, you're going to have to know how to put things apart and how to separate them. So automatically 100, because this is a nice number, okay, and they tell you 20%, you know that this is 20. And let me get my purple back. Why do you know that this is 20 alive? Because it says 20%. And people will sometimes do the extra math and take 20% off of this, and then they'll say, oh, it's 80. But no, it's not. It's 20%, which means, so have your mind think about what's going on. 20 is less than most. So make sure you understand that it's less than, you could even set like a goal. It's less than 50%. Okay? So that's there. So it had to be because it's 20%. Now this is a nice number with this 100. It makes it even. Okay? 30% would be what? 30% would be 30. See? So this is happening very well for you. Now here is the other situation. The names are changing around, so you have to pay attention to that. Those of you who take the grammar and writing test for graduate school, this is the beginning of this, because they do that all the time and they start playing with your mind. They say, what are they talking about? So they start with Sammy and Andrew, then they go Sammy first, then they go Andrew second, and then they turn around right here and they say 40% of Andrew's. Okay, so the test writer is thinking that you'll want to put 40% here, and guaranteed they will give you that test or the possibility of that on an exam, and you will go for it. So do not do this. Please make sure we keep everything straight. The 40% goes over here because it's A for Andrew. So 20% of Sammy's were live. What is the total live sample? So your total live sample is going to be 20. And what is, if you had 25 marine animals collected, what is 25 times 40? And I want you to think of it this way. 40% is less than 50%. So we already know it's got to be less than 12. And $12.50 is going to give you $12.50 is going to give you a nice round even 25. So 0, 0, 1, 3, 5, 25. Okay, so 40% has got to be less than $12.50, because half, which is 50% like this, is $12.50. So it's got to be less. So when we multiply 5 times 0, 0, 2 times 0, 0. Okay, this is a 0 here. 5 times 4 is 20. 0, carry my 2. 4 times 2 is 8. This is 10. So that's $10, or 10 cents, so 10, whatever. It's 10. I think in terms of dollars, because if you can start making money if you start making this in terms of dollars, you'll be fine. So this is 10. So now they want to know the total live sample. So over here, your live sample was 20. This is 10. So what's 20 plus 10? It's 30. So when we go on the next slide and choose, we can start looking at how people get these wrong answers, and that way, you can see what they're doing, and we don't have to ridicule them or make fun of them, because these answers were set up on purpose. Answers. So now our answer was 30, so this is the correct answer. So you'd circle it, bubble it in, that's correct. How would someone think it was 35? Well, if you had 20 here, and you had 25 here, and not 20% here, you wouldn't get it there. Let's say you had 25 total, and you did 10% of that 25, and you messed around, and you said this was 10, which left 15, and then you took this 15 and this 20, and then you added, you got 35. Okay, so that is what's called a distractor, and that's what your people want you to do. Okay, they want you to choose that one. How would you get 80? Okay, whoops, you guys know me by now. You know I overcomplicate things. Very much so. Okay, so this is a distractor. How would you get that distractor? Well, you would get that distractor by thinking that this 80% that was left was the sole answer, and then you leave this alone. Which leaves us for the next slide. how would you get that distractor? Well, you would get that distractor by thinking that this 80% that was left was the sole answer, and then you leave this alone. Which leaves us for the next slide. 80 would be the amount if you didn't think right. If your mind mentally thought 20%, but you wrote it down as 80. And if your mind did this and said 40% of 25 is 10, and 15 is what is left. So you put them together, and you had 80 plus 15. That's where you're getting that from. This 25 plus this 40%, which is 10, this 15. You add it right, there's your answer, which of course is wrong. So that's how people choose distractors. They don't look at what they're doing, and their mind is playing with them, and they're like getting all tensed out because, hey, we only have so much time left. We only have so much time left, that they're not looking at what's really going on, and then their mind plays a trick on them. Before you know it, they've chosen the wrong answer. So start looking at what's happening. Make sure you're going back and thinking through what's happening so that you don't get these answers wrong. So now that we know how to start getting what the questions are asking, we can do Sammy and Andrew's data. So, and this is written backwards, not on purpose, but it is. This is collection 3, this is collection 2, this is collection 1. So you have to look here and you have to know that this is 1, even though it says this is 1, but there's nothing here. And collection 2 was orange, so this is 2, this is 2, and you have to do backwards. Okay, now this is 3 is green. Okay, so make sure you notice tiny little details like that, and make sure you get them straight so that if someone asks you a question about the data, okay, so it says for this part of the project, Sammy and Andrew worked together. Which fish has the same amount during the first and third collections? Well, the numbers are here for you. Sometimes the numbers aren't, and you have to be able to see that these are done in twos. So 1 would be halfway between this 0 and this 2, so that's 1. 3 would be halfway between 2 and 4. 5 would be halfway between 4 and 6. And 6 would be between halfway and 7 and 8. 9 would be here. 10 is here. 11 is halfway between 10 and 12. And you see what's going on here? And 15 is right there, which is somewhat halfway. So here's what you have to do. Some people forget to set this up. So here's what's going on. You try to look and see which ones are line up the same and which ones are even, and it said during the first and third collections. So your third collection is green, your first collection is blue, so you have to look for blue and green that line up. So, and for the clownfish, none of them line up. For the tadpole, you have your third collection here, first collection here, they're both 10. Okay, here it's 8, 5, and 2. Here it's 15, 2, and 5. So now your answer is going to be right here in front of you. So it's D, the tadpole. Just look at what's going on and don't make these harder than what they are. Which group of fish grew the most during the 3 collections? Well, which one started from the least and grew the most? So the clownfish was at 0, went to 4. That's only up plus 4. The tadpole started at 10, so it started at a greater part, but it only went up plus 2. The red herring were at 2, but guess what? They went up to 8, so that's plus 6. So the goby are here starting at 2, but they went up to 15, so that's plus 13. So your answer is going to be here, and you have a way of checking it mathematically, even though you can look at it and see here. If you want to check yourself and you want to make sure you're right, this is how you look at it mathematically. So your answer, and I'm going to circle just the B. You guys don't circle anymore, you dot. You go, okay, and there's space here, and you just go put the dot, and so your answer is B. So there are all kinds of ways you can get questions from data collection. Now, we're going to move into something, we're going to multiply. So I'm using X as a variable. A variable is something that stands for something else. So when I say 1 times equals G, what I'm saying is how many goby are there. So I'm saying 1 times 5 for goby. So I'm going to write this here. And that's the number of goby in the first collection. 1 times 5 equals 5. Red herrings, first collection were 2. 1 times 2 equals 2. That's your red herring. And then your tadpole collection was 1 times 10. So 1 times 10 equals 10. And you didn't have any for your clownfish. So 1, any number times 0 is going to equal what? 0. So when I get ready to make a variable of a times, I can also make X a variable, and all I have to do is move the variable around. I'm going to show you how. Guess what? Whatever variable you want to use can be anything. It can be G for goby, it can be R. You could even put a variable together and do RH. You just have to use it in both spots. It can be C, it can be T, and since this was a total data collection of marine life, it can be M, it can be F. But you see how I'm usually choosing for a variable a letter. So this is the total collection. I took the X off and I put 5. When you put brackets here, you're multiplying. So 1 times 5 equals 5. And I wanted to keep the G here so you know it's 5 goby fish. 1 times 0 is 0. 1 times 2 is 2. And 1 times 10 is 10. So you have all the fish collected, right? Goby, red herring, and I put R for red herring, tadpole, T, and C is clownfish, and G was your original, was goby. When you get ready to add them, if you were multiplying, this is 1S, and that means 1 sample. 1 data sample collection. So 1S equals 17. Why am I doing this? Because if you wanted to mix this data collection with another data collection, you have what Sam and Andrew's first data collection of marine fish is. And then you can start adding. Okay, that was just the first collection though, right? That was just the first collection, the blues. Blues right here, and this is 0, but that's still a data collection. So the first sample was a total of 17 because 5 plus 2 is 7 plus 10 is 17. Now look, this is Sammy plus Andrew had a total of 17. So if I change and I said I want a word problem, and I want to do a word problem to figure out what's going on between them, and I want to do a word problem to figure out what's going on between them, how could I write them as variables? S for Sammy, A for Andrew. What could I do with this to explain something? Well, I could say Sammy and Andrew collected 17, but Sammy was 2 times the amount of Andrew. And 2s plus A equals the amount, which was 17. Well, that means I have to know Andrew's amount, have to know there were 17 total, and Sammy was 2 times what Andrew did, so I would put 2s here. So we're going to go over this on the next. Now, on the other slide, I had 2s plus A, that's an awful S, 2s plus A equals 17. I'm going to tell you why, because of the word problem. But I have taken this out and I've changed it, because if Sammy is 2 times Andrew, I want to find Andrew's spot first. So I'm going to change them to A's. And now we can review the question that goes along with this. Okay, so Sammy collected 2 times or twice as many marine life samples as did Andrew. So how many samples did Sammy collect? Now in total, they did 17. So let's start lining this up. This is total, and this is going to be a very, very odd number. You want to solve for A, but remember, whatever A's value is, A equals Andrew, and we're looking for Sammy. Okay, so Sammy is what? 2 times A. Now, 2A plus the regular A is going to give you the total collection, or the total sample. Andrew's A, and 2A is Sammy. So you're substituting. You're going S plus A equals 17. But when you put them in, you get S over here plus A, but 2A is what Sammy is going to be. So you get 3A equals 17. Now, you have to solve this and get rid of the variable. So when you get ready to get rid of the variable, you're going to do, solve for what Andrew's original amount was, but you're going to divide this 3 out. So you have to divide the 3 out, and this is when you have to know what PEMDAS means. And PEMDAS is please excuse my dear Aunt Sally. And you have to understand what this means is parentheses, exponents, multiplication, division, addition, and subtraction. And if you are trying to, if you were trying to just like solve, remember, you multiply first, you divide second, and add and then subtract. Now here you multiply. 3 times a is 3a, but you cannot solve for a just by dividing. You don't divide a out because that just takes it to this side. So you divide common terms, and that's this here, and you're going to get your answer. Now for those of you who are just beginning 3a equals 17, you cannot find this variable's value until you do some things. So 3a is 3 times a, you multiplied. And this is PEMDAS, please excuse my dear Aunt Sally. You don't have parentheses, you don't have exponents. So you multiply. Now you get ready to divide, but here's the deal. You need a reciprocal. 3a is the same as saying, when you do a reciprocal, you're doing 3 over 1 a times its reciprocal, and you don't have to do the 1/3 a, so it's just 1/3. And then a stays by itself, so what happens is you can cancel out the 3's, cross multiply, cancel out the 1's, and I didn't mean to draw it by a is left by its lonesome. Boy, it gets really hard if you don't remember what's going on. So a is left alone. So that's what we did. A is going to be left alone. Now this is going to be what? 17 over 3. Hey, not as hard as you thought. Okay, so now a equals 17 over 3. Well, we can now, there's no adding going on there. We've multiplied, divided, there's no adding. So we can still divide, and then you can get the answer from what's left on. No. Okay, so we had here a equals 17 over 3. So we take 3 into 17. We have 3 times 5 is 15. So 3 goes into 17. So that's 5, 15, remainder 2. So that's 5. That's 2. This is 5 2/3. Okay? So 5 2/3 is also the same as saying 5.66. And so now we subtract from 17, and we're going to get a decimal or a fraction. I'm deliberately using a decimal to show you how this works. Minus 5.66. We've got to get our math straight. That's 4. This is going to be 9 minus 3 because we borrowed, and we borrowed here. This is going to be 6, and this comes over here. That's 6 minus 5 is going to be 1, and this 1 stays here. Sorry about that. We leave the 6 here, and we don't have to borrow. Okay, we leave it here. It's just a plain 6. 6 minus 5, so it's 11.34. When you add back up, that's what you get. And so, surely looky here, this is going to be Sammy's amount. You need to check yourself if you do something like that. You have a 6 here. You didn't have to borrow from here. You just carried straight down. You need to check yourself so that, remember, these are inverse operations. So 11.34, the same as saying 5.66. And please don't be embarrassed. Scientists do this all the time. They check behind themselves to make sure something is what they say it is. 4 plus 6 is 10. 10 plus this is 4. This is 0. Carry my 1. 7. And adds back up. It is 17. 17.0. You can get rid of this. That's 17. So he's double. Now here's the thing. 5 plus 5 is 10. but this is 5.66, so we say this. We go approximately like that, almost 6, doubled, and this is almost 12. So it checks out. So this is Sammy's amount. So he did double, and that's your question. Now here's the situation. On an exam, they may give you something like 11, 12, 13, 14. You're going to have to figure out how to make sure you get the right answer. So we'll go over that on the next slide. So now if you want to do a word problem like this, how much more did Sammy collect than did Andrew on the remaining 2 collections? If Sammy collected the same amount on the second collection, but Andrew collected twice as much as Sammy did in the second collection. Now remember, the first collection is blue. Remember, first is blue. Second collection is orange. So we have this 2, this 5, this 2 is the beginning, this 12, and this 2. 2 and 5 is 7, 7 and 12 is 19, and 19 plus 2 is 21. Okay? So now when we get ready to do the third collection, and that is the green one, we have 15. So that's here. We have 8. That's here. We have 10. And we have 4. 10 and 4 is 14. 14 and 8. I'm just going to add this out for you. Let's double check our math. It's always double check. So if you're doing samples later as you get older for data collection, you're not going to get it wrong. That's 22. And then 22 plus 15 gives us the 37 we're asking for. So we have both our numbers except for this 2, 5. And so we have everything here. 2 and 5 is 7. And 7 and 12 is 19 plus 2 is 21. So now, that's just the first part. Okay, we have to now start looking at what the words are actually saying. We just divide by 2, as we've done here. There are 2 people. You know, two. If you add 10 2 times, of course it's 20. And so of course if it's 21, it's got to be a little bit more, and it is. It's 10 and a half. And this is a decimal lesson for those people who forget what decimals are. You can, or forget how to do them, not what they are. So it's 10.5. Then that's a separate lesson. So both Andrew is, and 10.5 is the same as saying 10 and a half. And Sammy is 10 and a half. Okay, so they both collected an equal amount. As we move on to the next one, we have Andrew collected twice as much as Sammy did on the second collection. So you remember this problem, this equation, S plus A equals the amount. And the amount was 37. So Andrew equals twice Sammy. So twice Sammy plus Sammy equals 37. 3S equals 37. Now this time, Sammy is going to be used as an S. So when we move over, we have 3S equals 37, the reciprocal of 3. And remember, we make this 3 over 1 times 1 over 3. And then they cross out. 3 times 3 is 1, 1 times 1, so that becomes 1. This is 1s. And then this is 37. This just goes 37 times 1, and this is 1 times 3, so that's 37 over 3. Now we're going to do 3 into 37, and since we use the letter S, S stands for Sammy. So this is 1, 3, 0, 7, 2, 6. So it's like 1 third. So this is really 12.33 is Sammy. But keep in mind now that Andrew collected twice as much. So twice as much is 24. So 12.33 times 2, and I'm going to add 2 zeros here so you can do this. Okay, and we're going to continue this on the next slide. Okay, so this is group collection if we're getting ready to do like doubles. So Sammy and Andrew asked Lucy and Ravine to help them collect data. Sammy and Andrew were group 1, Lucy and Ravine made group 2. If the groups were 1S and 2S, how could we determine how many more fish group 2 collected than group 1 in the first data collection? So the first part of your question is you just set them up as 1S plus 2S equals 37. But this one over here asks you a different question, and we're going to go move on to that. Okay, so twice as much as one group, and we already did this one with the first problem. This is 1S plus 4S equals 21. 1S plus 4S equals 5S, so 5S equals 21, the same process, 1/5 times 5 over 1S. This is 21 over 1 times 1/5. This is 21 over 5. So your answer is 4.5. Now, if you remember your fractions, this is 4.20. And remember 5, if you ever want to find the tail end of a fraction, it's 5.120. You put the decimal here. This would be 0 because 5 cannot divide into 0 here. This is 1. And then you can bring the decimal down, although you don't have to. And this is this is your decimal here, 0.2. And that's 10. And only because decimals end in zeros do you even put 4.2, do you put the 0. But this 0.20 means 20%. So 4.20, I kept them in decimals, times 2 is 8.40, and there's your answer. Now, if you look at what you're doing the 1S plus 4S. You're starting to set up multiple equations. Equals 21. You're starting to get some of this stuff, really, some of these things that are going on here straight. Okay? Now let's move on. You have something called a FOIL method. We will go over this, but I want to go over degrees before we do. You have a second degree here because this is 6x to the second power. You have a first degree because this is implied as a 1x. And you have a constant. Why is this a constant? There's no variable. So when we get ready to add, subtract, and multiply, which is really what the FOIL is used for. The FOIL is you're adding and you're multiplying and possibly subtracting, because you're going to subtract over here and you're going to get 7x. Okay, and then this is minus 3. This doesn't have a term, but you're actually doing it all because you're multiplying first because of these brackets. Brackets. So just make sure you know what your degrees are, what you're doing, and how they multiply and what they do. And remember, 2x times 3x, this is really 1x and 1x. So when you add them, the powers, you multiply the numbers and add the powers. This is 6x squared. So this first term here, first 2x, 3x. Okay, now it's telling you to do your outer term, which is 2x. Times negative 1. That gives you negative 2x. I put it here. Then you're going to do your inner term, which is 3 times 3x, which is 9x, I put here. Now it's positive. This is positive, this is positive, so it's 9x. And then you're going to do your last. Your last term is going to be positive 3 times negative 1, which gives you negative 3. And that's how you get your FOIL method. It looks complicated for now, but we'll discuss it as we move on. FOIL method, get used to this. When you write an equation and you write something out, you have 2x over here plus 3. And I want you to look at this. This is called the area method. I call it the box method, but it only because you use a box. This here, it's a box. You go 3x minus 1. So you know, just try to remember that, and then that's it, and then we're done. We're not going to get into this right now. We're going to use this later with word problems.